Okay, hi guys. So in this lecture we'll be starting off on the topic of other one to eliminations. We will be seeing dehalogenation reactions. Okay, so let me write down the topic first. We'll be talking about dehalogenations of um, dehalogenation reaction in the topic of other one to eliminations. Okay, and specifically we'll be talking about dehalogenations. Okay, so suppose we have this reaction in which we have on CH3 here. Then if we react it with NaI in presence of acetone or zinc dust, then what will actually happen is we'll get something like this. Okay, plus obviously IBr and NABr. Okay, this is nothing but a vicinal dihalide because two halogens are on adjacent or neighboring carbons. This is called vicinal dihalide. Okay, and how this reaction is scattered. So the reaction mechanism is acid is a E2 reaction, but if we have, let's suppose, a monohalide, something like this, then what actually happens in this case is I minus will be acting as a nucleophile and we would get something like SN2 reaction over here, and we would get I here. Okay, and plus NABR. Okay, so I hope you are clear how this E2 reaction takes place. We have I minus, and I minus will be actually acting as will be coming in for removal of Br plus from here, and at the same time Br minus will be removed from the anti position, creating a negative charge and positive charge here and a double bond character here. Finally we'll have this as the final product. Okay, then we have another example in this concept only. Suppose we have something like this, CH3 and 2Br are here, and we have hydrogen here. So what actually happens in this case is we again reacted with acetone. So what would be the product form would be something like this. How? Because these two Brs have to be anti in position to each other. So if we draw the Sawhorst formula for this, suppose this is the first carbon, so we have Br H CH3 here, and again we have on the back carbon we have Br H and CH3 here, and we just saw that it's a anti-elimination. Okay, so these two Brs have to be anti to each other. So what will next happen is the rotation or conformer will form across this bond. Okay, we would get something like Br will be placed here, H would be placed here, and CH3 would be here. Obviously assuming that we are allowed to rotate the bond, and this is not a only compound we have formed. We have to determine the possibility of any compound. Okay, but had it been not written like that, then obviously it would have been a no reaction. Okay, so in this then comes NaI into the picture, and we get something like this as the final product. Okay, now let us discuss the characteristics of this reaction. Characteristics of other one to eliminations reaction or dehaloginations. So characteristic is first, in dehalogenation reaction of two halogens, means the bond formation of two halogens happens and the bond breaking of two C and Br bonds happen. Hence, in dehalogenation, two halogens must be anti to each other. So, in dehalogenation, two halogens, obviously on adjacent carbons, must be anti to each other. Okay. Second point is, when vicinal dihalide reacts with NAI acetone, E2 reaction takes place. Okay. So when vicinal dihalide reacts with NAI acetone, E2 reaction takes place. Okay. Third point is, monohalide reacts with NAI acetone, then SN2 reaction takes place. So when monohalide reacts with NAI acetone, SN2 reaction takes place. Please do keep revising from the previous video lectures or from a previous set of video lectures. The SN1, SN2, E1, E2, SNI, all these type of reactions will be frequently encountered in our next set of or next coming video lectures. So I hope you are pretty much clear and very much confident about all the previous concepts regarding the reaction mechanisms which we have discussed, be it addition, substitution, and things like that, right? Or elimination. SN2 reaction takes place. And then the fourth point is, the formula of the cat, which is cis anti 3O, is still valid, or you can say valid or applicable on dehalogenation reactions as well. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples of dehalogenations. Till then, good luck and goodbye.